So this is Sinusoidal Waveforms by Megan Valencia. Now this is the formula for a sinusoid. It has three key parameters: the amplitude, the frequency, and the angle. First we'll go through the amplitudes. This determines how high or how low a sinusoid reaches. This example sinusoid has an amplitude of 1, but if we were to change its amplitude to 0.5, it would look like this. Now, frequency determines how many cycles it goes through in 1 second. This example sinusoid goes through 2 cycles, so it's 2 Hertz. But frequencies can also be measured in radians per sample, which is how many revolutions it goes through in 1 second. This one goes through 2 revolutions, so it would be expressed as 4 pi radians per second. Now, if we doubled the frequency, it would look like this, and this is 4 Hertz. Now, phase offset or phase angle determines where in the cycle does a sinusoid start. This example sinusoid is the function of cosine, so it starts at the maximum point of its cycle. Now, if we changed its phase angle to 180 degrees, it would look like this, and notice how it starts at the bottom of its cycle now. Now, phase differences is relating to the difference between sinusoids' phase angles. Now, if we change the x-axis to radians, we can see that the blue is leading by about 1/4 pi, while the red is lagging by 1/4 pi. But if you couldn't see where these started, you could argue that the red is leading while the blue is lagging, but strictly speaking, sinusoids last forever, so it seems a bit redundant to talk about who is leading and who is lagging. Now, discrete signals can be expressed in radians per sample. If each of these red dots represented when a sample is taken for a discrete signal, then this would be expressed as pi over 2 radians per sample. If we doubled it, it would be pi over 4 radians per sample. Now, complex numbers can also be used to represent sinusoids. Mind you, this can only be done if the frequencies are the same. So if we add these two sinusoids together, it would look like this one, the one in yellow. But how are complex numbers used to represent sinusoids? Now, if you have an Arrow diagram and you pick a point, draw a line from that point to the origin, then that line is now representing the magnitude or the amplitude of a sinusoid, while the angle created from that line to the x-axis is now used to represent the phase angle of a sinusoid.